Alright guys, we're back again this week. Last week we talked about oxy-fuel welding and its uses and purposes and what types of metal you should weld with it and when would be a good idea to use it. This week we're going to talk about arc welding. Student learning outcome is going to be students will learn proper steps to prepare for arc welding and will be able to identify the different types of arc welding processes as well as know how to apply them. First off, we have small, also known as shielded metal arc welding, commonly referred to as stick welding. How does stick welding work? Stick welding uses rods or electrodes that are held by an electrode holder, also commonly referred to as a stinger. And once you clamp that rod into that stinger, it'll carry a current from the rod to the metal whenever you touch the rod to the metal. Uses of stick welding is commonly used for structural welding. It can also be used for carbon steel pipe and used for bigger steel pipe, mainly for oil lines and such. It can be used to weld carbon steel, low alloy steel, high strength steel, cast iron, malleable iron, bronze, nickel, stainless steels, and aluminum. Advantages are it's cheap, can be used to weld most metals, can be used on a variety of thicknesses, and in my opinion it works better on a thicker metal. Provides most mobility. If I wanted to, I could take and pull out 100, 200 foot of lead from a machine and weld 100, 200 foot away from a machine. There's less prep work. You don't have to clean quite as good as you do with TIG or MIG. Disadvantages may be frequent starts and stops to change your rod. Each time you burn up a rod, you got to hook another one into your stinger. There's more cleanup because your electrodes or your welding rods the flux on them could create a slag, or it will create a slag over your welds, and you have to chip it off with a hammer or use a brush to clean it up whenever you're done. Stick welding also produces a lot of smoke and fumes. That's something to be cautious of because smoke and fumes cause upper respiratory issues, and it's not something you really want. And as long as you ensure that you clean your metal good, maybe you won't have that problem. Know what you're working with. It's not recommended on metals thinner than 1/16 of an inch. Here's an example of an improper stick weld. It's got a lot of hills and valleys, and it's high and low spots, and they just don't look uniform. Here's an example of a proper stick weld. You can tell it's got a uniform kind of coating or top coating to it. It's got that same little ripple all the way down. Next process we're going to talk about is going to be GMAW, also referred to as gas metal arc welding and commonly referred to as MIG welding. How does MIG work? MIG welding is a wire-fed process where wire is pulled off of a spool and it's pushed through a gun, and that gun and the tip of it's going to have a contact tip. And that contact tip is going to send an electrical current through the wire, and whenever the wire touches the metal, it'll begin to start an arc. MIG welding generally requires shielding gases. CO2 or argon may be common. My preference is 75% argon, 25% CO2. Depends on what you're welding though. If you're welding aluminum, argon might be your better choice. Here's an example of what MIG setup looks like. You got your MIG gun here. And wire is going to be fed off this spool from your welder through this wire wheel. It's going to feed your wire. It's going to come through your hose, come back up, and once it comes to right here, this is where that contact tip is. And as that wire is pushing through, it's making contact with that contact tip, and it's going to carry your arc. Uses of MIG welding. MIG welding is very common in the automotive industry, and it can be used for welding body panels or exhaust, or maybe patching little holes or something that you might have to do. Another area that MIG welding is common is for agriculture repairs. If you got a quick fix that you need to do, maybe on your tractor or something, it'll hold for the time being. It's also common for home repairs. Anything that you got that might be light duty or something, you might need to weld. MIG might be the way to go if you're an experienced welder. Can weld mild steel, stainless steels, and aluminum. Some advantages of MIG welding are it's great for welding thin metals. You get a continuous wire feed for minimal starts and stops. There's no slag cleanup. It's good for gap filling because as that wire's pushing in, you're constantly filling in a big gap if you got one. Simplicity is a big thing with MIG. Just about anybody can MIG weld. As long as you get the basics down, it's pretty easy. Disadvantage is it's not very versatile. Generally speaking, you usually have about a 10-foot lead coming from your machine to your MIG gun, so you can't really weld too far away from your machine. Uses shooting gas, and the reason why this is a disadvantage is because if you're welding outside or maybe somewhere that has a draft or something going on, it could pull your shooting gas away and cause a poor weld quality. Not as easily movable as stick or TIG. Talked about that before. If you only got 10 foot of lead coming between your machine and your gun, you really, unless you want to carry your machine around with you everywhere, it's really not an ethical process for mobility. It's not used for welding pipe. It's probably the weakest of the three types of processes we're going to talk about today. Here's an example of a proper MIG weld. It's nice, smooth, slick bead. Here's an example of an improper MIG weld. You can tell it's got all these pores and holes in it, and it looks like it might not have got quite the penetration as the proper weld here. Not quite the coverage neither. Next process, and the final process that we'll be talking about today, is GTAW. It's gas tungsten arc welding, more frequently referred to as TIG welding. TIG welding uses a tungsten electrode, which is held by a TIG torch. TIG welding also requires an inert gas or shielding gas. The most common one used is probably pure argon, 100% argon. It's good for welding stainless, mild steels, carbon steels. One thing to keep in mind is with TIG welding, you got a filler metal that's usually hand fed unless you've got an automated machine, which can be quite expensive, but this filler metal is going to be fed by hand, so you don't have quite continuous bead that you would have with a MIG. Another thing is TIG is also an acronym, just like GTAW is. It stands for tungsten inert gas. Here's an example of what a TIG torch is kind of compromised of. It's you get your gas nozzle right here, collet bottom, your collet, your back cap, and your tungsten. And how I like to put this together is I usually put my collet body in, then screw in my gas nozzle, but don't tighten it all the way quite yet. Leave it about a quarter turn loose. Then slide in that collet, slide the tungsten in there, and then apply the back cap. And you want to make sure you have enough stick out of your tungsten right here for your welding that you're going to be doing. And usually you want to keep your tungsten sharp to a point. Helps with precision, better arcing, better puddling, and you want to make sure that you get better control. Once you get that tungsten in there, you want to tighten that back cap and that gas nozzle, and that's going to secure your tungsten. You want to make sure the tungsten isn't loose enough that you can push or pull it out. Some uses of TIG welding. TIG welding is common for welding pipe. Doing automotive welding, if you got a roll cage or a chassis or something that might need welding, TIG might be the way to go. It's also used to weld stainless steels in the food industry. TIG welding can be used to weld the following materials: alloy steels, carbon steels, stainless steels, aluminum alloys, beryllium alloys, copper-based alloys, nickel-based alloys, titanium, zirconium alloys, magnesium, chrome, molybdenum steels. TIG has its advantages and disadvantages like every other process. Advantages are good for precision welding. You got that fine tip sharpen onto your tungsten. You might be able to get into a tighter spot with a TIG rig than you would with stick or MIG. TIG provides the strongest weld of the three. It's the cleanest weld and highest quality weld as well. Some disadvantages: once again, it requires shielding gas, and like I said with MIG, if you get wind or if you got a draft or something that could pull that gas away from your weld, that could cause a poor weld. Another thing, you got to keep your tungsten sharp. You got to, as soon as you start welding with it, each weld, your tungsten's going to get duller and duller, and eventually it'll ball up on the end. You want to make sure you sharpen it back to that point. If it balls up, take it out, take it back to the grinder, sharpen it. You got more consumables with TIG. You got to think about your gas cup or gas lens or ceramic cup, whatever you want to call it. Your tungsten, you can only sharpen it so many times before you got to change it. You got your back cap. That might replace or wear out. You might have to change it. Your collet body, you got to keep that in mind. They might wear out, go bad. You might have to change them. There's more prep required in TIG because it is the cleanest weld. It requires the cleanest preparation. You want to get as close to the bare metal as you can whenever you're prepping this. And a lot of people tend to like to rub an alcohol or something over it to keep the metal clean to help ensure the best weld quality. It's probably the hardest position welding process there is. And by position welding, I mean if you're in the field and say you got a piece of pipe on a machine or something that you got to weld and it's hard to get to, TIG might be difficult. But if you got pipe that you got on a pipe stand inside a shop somewhere and you just got to weld it up, it ain't going to be too bad. Keep in mind, position welds might be tougher. Here's an example of an improper TIG weld. You got a lot of holes and pores here. You can tell first off by looking at it, it just ain't going to be a good weld. Here's an example of a proper TIG weld. It's nice, slick, and smooth. You can tell just by looking at it. Cosmetically, it looks like it could hold. You can tell that proper fusion was ensured here and metal broke down properly for holding strength and tensile strength. And that's all we have for this lesson. Next week we'll be talking more about how these processes work and proper procedures for carrying out these welding processes, and maybe what kind of movements you use with stick, TIG, MIG, whether you have your gun, your torch, or your electrode. If y'all want to do some research on your own, feel free to. I'll see y'all next week.